So, thank you very much for having me here, especially for doing a DevOps talk here at Vision. And thank you very much, MongoDB, to have this opportunity to give the presentation for managing MongoDB with infrastructure as code, especially with Terraform. Today, I'm going to present you how you can move from manual management to automated management with infrastructure as code. But before we start, let's get some words about me. I'm Michael Ramstein. I work as DevOps engineer at Helvetia, and I'm technical co-founder at TechDoc. And I have the great pleasure that software development is my passion. So I like everything about it, but I'm completely addicted to automation and using APIs for that. So if I have to repeat myself, I'm definitely gonna automate it, and that's also why I'm here. And I strongly believe that the truth is always in the code, and I'm happy to find the truth if a bug appears. And I'm fueled, like many other developers, by caffeine and open source enthusiasm. If you like, you can follow me on GitHub, and 2 times a year I'm on LinkedIn or something like that. But you can find me there as well. So let's see what we have planned for today. First, we're going to look at the foundations, like ClickOps pitfalls. If you don't know what ClickOps is, I'm going to explain it later, and the advantages of infrastructure as code. Then we're going to have some spotlights on the tooling, that's Terraform, or OpenTofu. What's about that, I will explain as well, and the Terraform basics. And as soon as we have the basics, we can start with some demos. So I pray to the demo gods that everything goes well here, but I'm pretty sure about that. So let's start. What's ClickOps? Every time you provision your infrastructure through a UI, you're doing ClickOps. And ClickOps has it's super easy, but if I ask you, how do I actually set up a MongoDB cluster for my, let's say, mflix project, how I'm going to do that? Maybe you remember from the UI, so it's something about you log in, you choose your organization, you choose the project, maybe there's that button. How do I give access? Maybe that's also settings from the cluster, maybe it's not, but you just have to recall that from memories. And that's like a huge part in the ClickOps thing. You have to remember things. And the hard thing about remembering is it's pretty hard to remember things. So there's like this funny example of the doorway effect. When you think like, yeah, I'm gonna do this in that room, you walk into the room and completely forgot what you were actually planned to do. Go back to the other room and say, oh, okay, yeah, that was it. And yeah, so that's the same with provisioning things through a UI. You have one window, do something, another window, whoa, what was the setting again? Let's have a look at the documentation. Okay, good. And another thing from recalling memories is those change. So there's a good example of eyewitnesses in court where depending on their background, they experienced some other memories for the exactly same situation. So that's hard too. So why not doing ClickOps? First of all, it's error prone. If I'm going to do the same task 10 times, you can bet that I'm going to mess up 1 time. It's absolutely sure repeating myself 10 times means that somewhere I'm going to forget a checkbox, I'm going to switch the drop down to the wrong value, and that's an issue. And most of the times there's no audit log or something like that. It's pretty hard to track who changed what exactly when in the UI. It's slow and risky. Especially if you need to make changes in a production system, doing those manually needs time, like page loading, choosing this value, choosing that value, save, wait, do the next thing. So that needs time, and especially if you have a downtime means your company loses money. And there's also like those knowledge silos where just one person in a team knows exactly how to set up your MongoDB cluster. Except for, the rest of the team doesn't know it. But for this, you can say, hey, all those things can be solved by good documentation, right? Well, it depends on who is reading the documentation. For example, if you say to start, press any key, and you have someone that says, yeah, I'm not gonna press anything, I'm not 100% sure, any key is missing and he can't do anything else. And ClickOps just doesn't scale. I mean, if you have one infrastructure, or let's say one cluster, one database, you put your search index there, super easy. You can do that with ClickOps. But if you have to do this for different stages, exactly the same 10 times, and also like in another cluster, things get pretty hard, especially when someone just changed a value in one stage and you don't see the difference there. So here comes the solution. Why infrastructure as code? First of all, it's consistent. If you do infrastructure as code right, you will get the same infrastructure every time you run those things. This means also like you can automate those things, and you can like add collaboration. Since this is code, you can also add version control to it. You can add pull requests, and like every time a pull request gets merged, those changes will be made on the infrastructure. This means also you get this audit log from your version control, who changed what when. And this also gives you a bit more of a security part where you can, like, just one user really needs admin access and the other just need access to those infrastructure as code repositories, and everyone else on the company just needs the permission to add pull requests. So this gives you like a huge flexibility, and you don't have to give out admin access to users just to change some values. Or you have the bottleneck of just one user changing those things in an admin UI. So I'm always say Terraform, but if you look at Google or looking for Terraform, you will also find OpenTofu. And to this I will explain a bit more later, but now what's about Terraform especially? There are a lot of tools for infrastructure as code. There's Ansible, Chef, Puppet, and so on. And there's Terraform. The good thing about Terraform is that especially when you're doing things with Kubernetes, you just have those definitions, and you can also like build your own modules. We're going into that later to make it provider agnostic. And this gives you the flexibility to simply change things, and you don't have to change a whole documentation where like, yeah, you click there and there and there. And also Terraform uses the declarative syntax, so you just define what should be. You're not like writing a recipe for a cake where you say, yeah, put that in, put that in, put that in. And if you follow those steps, the cake will always be the same. You just say you want exactly that cake, and that's much more simpler. And you also have like this situation should be, and what's the actual situation. So the great thing about Terraform is state. Terraform itself has its state management. I will go into that later. And this is like, if I'm going to create a resource, Terraform writes down, hey, I created this resource with that ID. And that means later, the steps later on can use those IDs. Through the modularity, yeah, you can just make standardized modules and using them over your project. And there's also like the standard lifecycle of Terraform, where you just have init, you have plan, you have apply and destroy, and that's it. Those are the life cycles of your infrastructure. We'll see that later on. Now let's go to Terraform and OpenTofu. Terraform, or it's used Terraform, the wording, as HashiCorp created Terraform, but they did that on a different license. And last year they changed their license to the business source license, which means that if you're going to build a product like HashiCorp Cloud or Terraform Cloud, you're not allowed to do that with the business source license. The community said, hey, that's pretty dumb. We don't want those restrictions. So there was OpenTofu, which was just a fork of Terraform when it wasn't like relicensed. So that means it's actually quite the same, but it's different. You can use both. If you're going to use Terraform Cloud or HashiCorp Cloud, then use the Terraform thing. If you use anything else, feel free to use OpenTofu. It's all up to you. And that's for the basics. Let's start with the moving parts of Terraform. Terraform, as I said, Terraform uses state management. This means that we can, let's see if this works. We have our Terraform definition right here. Nice. And Terraform will look at this definition, and from this definition you get like, this should be in the world. So that. It will check, hey, AWS, for example, or MongoDB, hey, is this cluster created in this setting? And if it's not, Terraform will go on, create these things, and say, hey, I've created a cluster with this ID, and it has these settings. We'll have a look at the state file. That's great. You can just look at those things. And after that, it will compare back to what you actually defined. If you like say, hey, let's do that again, it will check, hey, what's in my state file, what's in the real world, let's see what's diverged, and so on. And this is something you don't get with Ansible or any other infrastructure as code tool I know. And that's also like the great part of Terraform, that you can move or create things, use those things for other things, and then you have like all these different things that are combined together and give you a picture of your infrastructure. Now let's have a look on how the Terraform definition goes. The language here is HCL. It's a HashiCorp something language, and it looks something like YAML, but it isn't. It looks like JSON, but it isn't. It's something between, and it gives you the opportunity to like add some more comments, and lists are easier. Yeah, but you will get a feeling if you know YAML and JSON. That's quite easy. But in the Terraform file, you write like Terraform, and then you can decide if you're using Terraform Cloud. This would mean you have this definition, or you have your own backend, like an S3 bucket, or you can just leave those things away, and Terraform will create a local state file on your file system. Now, just that I mentioned it, Terraform will also save secrets to those files, so don't commit those files. And if you're using like an S3 bucket, make sure that those things are encrypted, because yeah, you don't want to leak secrets. Next, there's the required providers. Since we're using Terraform, Terraform will have different providers, so you can interact with those. In my example, I'm using MongoDB Atlas. And how we can get to those names, we will find later on. And yeah, you just define what you need, what it's called, and what version do you need. And there's also like required version, which just means what Terraform version you're using. And this is important for the state file. Now to the providers, you have, or as I've told you, like we have this MongoDB Atlas equals something, and now we can also make the provider configuration. For this, we have this documentation. I will go into the live demo later on, but it looks like this. So those are a lot of providers you can use with Terraform, and you can use them interact with each other. So you can like create a MongoDB user and place the secret as Kubernetes secret, and fully automated. You don't have to copy usernames and so on. Or you can do a lot of other things. Just imagine it, and I guess there's a provider for it. Then there's locals. You can declare variables there just in your file. Define, hey, var1 equals world. You can use those variables in all local variables. You can do string interpolation with it. And you can also do like those maps. I guess it's called blocks in HashiCorp language. But yeah, just arrays or maps. And we have modules. Modules allow you to branch out the things from your main file and compact your logic there. So for this example, there's like my project search index modules where I define all my search indexes that should be present for this module. And all I need for setting it up is the coordinates on where those search indexes should be set up, project ID, cluster names, and databases, and that's it. I only defined those search indexes in the module, and everyone that uses those search indexes can use the module. And there's also like the fun part. In every module or every declaration you can use for each. This will give you like crazy fast build-ups when you say, hey, I need for every stage, for every database, I need those search indexes. I'm just going to place for each, give him the list of where it should place it, and that's it. No. Let's, I guess it's only three definitions left. Resources, those are things that create things. For example, we have the MongoDB Atlas search index. And those are just variables. You need to look those up in the definition of the provider. We'll come back to that later. Also here for each. And the data part is where you can get inputs from and use them in your resources. And here, for example, we're using a secret or we're reading out a secret from Kubernetes, and we can use those passwords somewhere in our Terraform script. And just Terraform will just compare those values then. When you do a plan, it says, hey, what's the secret? What's the secret there? Okay, it's changed. So I can do a password rollover absolutely with ease. And there's also variables. Those are things that you don't commit normally. The definition, the declaration of the variables, the definition you should commit. And there you just have description type and all other things. You can also add sensitive to it so it don't appears in the logs. And functions, a lot of functions. You will find out when you use Terraform yourself. In our demo, we actually don't really need functions, just a JSON encode, decode, but there are a lot of it. So let's come to the fun part. Just notice I have some more slides for it. Today we're going to use Terraform from an existing state. Declare that in Terraform, and then we destroy everything, and it should be back up the same when we do the same thing again. To get started, we need to gather all the infos. So we're gonna get the provider from MongoDB Atlas, and we need some access and so on. But let's just join you on my adventure. I just set up this empty project here. Let's see if it works. Can you see it? Good? Yes, yes, okay. Okay, thanks. So, if you're going to do a Terraform script, you start with the main.tf, and now we have an empty file. So let's go shopping and look for some providers. No, that's the wrong window. Terraform has its own registry. I just looked it up, MongoDB Atlas. And with every provider, you have this use provider. And here you have our Terraform definition and also like this Blanco MongoDB configuration. So we're just going to copy and paste this. And I'm absolutely sure if you're doing Terraform yourself, you will copy and paste a lot of things. Now we have our definition. We are using MongoDB Atlas here, and now comes the configuration. So we need access to that. Let's go to documentation and compliment here. MongoDB Atlas Terraform provider is pretty good documented. So we can just let's copy that one. Let's go back to our code. Let's paste it in here. And now he complains like, hey, you didn't define those variables. So we're going to define those variables. First, we have the public key. This is type string. We're not going to add any description here. just for the fun. And since it's called private key, we're gonna just add sensitive true to it. And yeah, let's try it out. I just added the alias TF. TF is always Terraform, but I'm just not writing Terraform all the time, so let's just do Terraform init. And now he will look for the provider that we defined here and initializes an empty state. And yeah, now we have Terraform initiated. If we do like a Terraform TF plan, he asks us for the variables we didn't define here. Since we don't want to do this all the time, we're just gonna add the Terraform.tfvars. TFvars is like for Terraform, those are variables stored. You can also change the name and just say .auto.tfvars, but I'm gonna just use the default tfvars. And here we have to define our credentials. So we have a public key and a private key, and this is the part where we really need ClickOps, since we just need to initialize the access to it. And let's go to the project settings, access manager. Let's go to API keys, create a new API key, project owner, just give him all the permissions. Normally you would just like start with minimal permissions, but since we have a demo here, I can do that. So now we have the credentials. The public key goes here, the private key goes here. Save and start the plan again. Now he has nothing to complain, says no changes since we didn't define anything. This is quite expected, but let's start with the cluster import. I already created a cluster. It's my free cluster. MongoDB has 3 tiers, so you can play around with those, and they also have like example databases. We're going to come back to that later. And in my free cluster, I want this definition of this cluster as code. So how I'm going to do that? There's a quite easy way to do this in Terraform, since you're just going to define, let's say we're going to define a cluster, and Terraform will go on and say, okay, that cluster looks different, here's the difference, and you can just use whether you want to take the state that's already defined or you want to use your state that you defined in Terraform. And to import something, you just go ahead and say, okay, let's just import those values until he doesn't complain, and that's all there is. So click that away. And here again, we're going to start copy pasting things. This is just the MongoDB Atlas Advanced Cluster configuration. I'm using this since the normal cluster configuration will be deprecated, or at least they say, hey, just use the advanced cluster. So I'm just going to use the advanced cluster. So I'm just paste this in, and if I'm now going to say, hey, plan this, Terraform will say, okay, I don't have this cluster in my state. I would like to create this thing, but we want to import it. So I'm going to first of all change the name. The name can be anything, but I don't want to change it later on. So I'm just going to use my free cluster as a name. And here it wants the project ID. This will be defined as a variable. So let's go ahead and say, yeah, variable project ID. The name of the cluster, I've already defined like my free cluster. Those are the things that I know and can see in the UI. Cluster type replica set, I don't know. Anything else, I don't know. Just see what happens if we're gonna go ahead and do a state import. Now I defined the variable project ID, so I need to define it here as well. So I need to look it up in my configuration. This is in the project settings, super easy to find those IDs, if you remember. And let's go ahead and plan. And he still says, hey, I would like to create this thing. So here we have the coordinates of our resource in Terraform in a state. And you can do Terraform import. And now you have to know, like, what are the coordinates that Terraform needs to import the states. I'm normally just adding bullshit to it, and it complains, and then say, okay, I need the project ID and a name. For the cluster, the project ID, I already know, it's that one here. And the name I know as well, it's called free cluster. So just go ahead and copy and paste it. It's my free cluster, copy and paste. And if the coordinates are correct, he will now import the state. Now what's the issue? Oh, so here. Nice. It was a special dash, an extra dash here, so it didn't work. And now have a look at the Terraform state file that he just created. And here we have all those information about our cluster that he just created, all those different things I can use. And if we're gonna now do the Terraform plan, he should complain about things being different. And he says, hey, you just have another region configured. Since we just copy pasted, this is expected. So we're just gonna take this region name, take it back to our definition, paste, and let's plan again. That's it. We just imported our cluster into our Terraform state file. And now, since this is already running and we have some search indexes here, let's import those as well. The thing here is it's a bit harder to get your IDs, or let's see the search index definition for it. We have this resource and the data sources. Resources are things we create. Data sources are things that you need as an input for resources. So we're going to use the resource for it, copy and paste it, add it here. And since the search index that I created is called movie title search, we're going to add this as name here. Project name is already defined as variable. The cluster name, this is one that we have from here. Like, it's already defined here, but if I didn't, then Terraform would know what the cluster name is. Let's just use this and name. So now, through this definition that I'm using, the advanced cluster, myFreeCluster.name, Terraform knows, hey, I need to need to provision the cluster, and then I can use this resource to make the MongoDB search indexes. So that's something he will create, and yeah, database also needs to be defined. Since this won't be changed in some more days, I'm gonna use it as a local, so I can commit it directly into the code and use it here as just a reference. Or I could also import the database as Terraform state, but I'm just moving forward and do this. So the database was called, let's have a look. And let's do a plan. He will complain about that he don't know anything about this MongoDB search index since it's not part of the state. So let's do the tf import. Let's add some bullshit. Now he has an error, so project ID, we know. Oh. And here we have the double dashes. So project ID, dash dash, cluster name, dash dash, And now he says, hey, you need an index ID. And this is a bit harder to get. You can get it through network inspection, or they also have like this data source indexes where you can list all your indexes. But this is much easier to do since we're not gonna do a lot of data things. I'm just gonna use the network inspection. Since the MongoDB Atlas uses the API, you can fetch out those from here. So here's the index ID, add it to here, press enter, importing, plan, and let's see what he detects as changes. So we defined a MongoDB search index with the wrong collection name. We called it movies, and it's collection, or we defined collection test, but in the cluster it's called movies. We want movies as well, so let's take those things into our definition. Paste it here. We will create an analyzer, but it's not created an analyzer, so we remove that. It's just like the opposite of what he wants to do. And there's also like this mapping fields where you have this JSON encode things. Check. Also paste this thing here. And we don't create this search analyzer. Plan. Now it changes. Nice. So we have the things that I created manually now documented in form of code. I can commit this, and everyone sees that the actual definition for my mflix application looks like this. We have a cluster with an M0. We have a search index that has the mapping fields, the mapping in dynamic, and the mapping field for string. This could actually be false. Let's see what happens here. Yeah, he will complain. So we have the mapping dynamics turned on. I actually don't want that. And we have manually defined mapping fields. Now the fun part about Terraform, or if you're not if you're not going home and say, yeah, I'm going to use Terraform for the rest of my life for provisioning infrastructure, here's like a really great part if you're in a team and everyone has like admin access to your cluster. Let's say someone goes ahead and says, hey, I'm gonna change this to false, and I'm gonna do, yeah, I don't know all the fields on this, but this is enough for showing you what I mean. I'm gonna just make a change. Nobody knows what I just changed or why I changed it. I just changed things, and the admin of the project now will go ahead one day, make a Terraform plan, or if you're using Terraform Cloud, you have this like drift detection where it just detects all day, or at least all day, and says, hey, you have a change from your actual infrastructure to what you actually defined. How comes? And now we see, hey, somebody changed the mapping dynamics from false to true. This isn't defined in the code. So what I'm going to do here, maybe I say, this is wrong, this should be false. Or I say, yeah, well, actually, that one was me. I just didn't document it somewhere. I just made it short change, test it. Yeah, it works. Forgot about it. So let's make it false. Terraform plan. And then I would normally commit it. Yeah, so nice. Now let's say, okay, we just provisioned all our things, the project finished, we need to clean up our things. And if you're on AWS, those things are pretty hard if you're using the UI, and you maybe get a bill from, hey, you didn't deprovision your IP, or you didn't provision a backup somewhere in the UI, and you have no idea where those codes come from. When you've managed everything in Terraform, you can just go ahead and say, hey, destroy this thing. And he says, like, hey, do you really want to destroy this? And if you go ahead and say, yeah, but normally it shouldn't destroy my cluster, like this should be part of the code, that I'm not going to destroy cluster info, there's like also this pro tip. It's lifecycle management. You can add the prevent destroy arguments to your resources, and there Terraform will say, hey, I'm instructed to not destroy this thing. So let's just show it how this looks like. We're going to say the advanced cluster has the lifecycle definition of prevent destroy. So, zack. And now he complains about, hey, this instance really can't be destroyed. So you have to go ahead, remove this line and say, yeah, I'm really going to destroy this cluster now. Yes. And now he goes ahead and destroys my cluster. Ooh. I guess the class. Yeah. So my overview: cluster is shutting down. That's absolutely what we want. And with our, so okay, we have support time. Now we're going to provision the exact same thing again, and it will be the exact same thing, except since we have created databases and have placed search indexes on this database, Terraform will complain, or at least the MongoDB driver will complain and say, hey, I can't add this search index to a database that just doesn't exist. So we're just going to create a cluster, an error will appear, and we're going to load the sample data in. And yeah, that will be the fun that we're doing here. So now destroy complete. Nice. Now we do like an apply again. Hey, you just said I should create those things that you defined, and so I say, yeah, please create those things. And since we're now having defined a search index that's depending on the cluster, he will first create the cluster and then do the search indexes. So that's one absolutely fantastic feature about Terraform, where you just have the opportunity to use variables from other definitions that you created, like an IP or MongoDB server address, and use this for something else. And he will just figure out what's the correct order to provision all those things. And this takes about 3 minutes or so. So we just go ahead with the presentation and wait. Normally, you would like just wait or get a coffee and come back to your desk and say, okay, now I need to create this, and now I do that. With Terraform, you just define something that takes, let's say, an hour, and you just press OK and do something completely else, and when you come back, everything is set up. So, here. We're going to continue from here. Now the cluster from scratch, that's what we are actually doing. And now putting things together, I told you about the mflix application that was using the index. I'm just going to show it to you. This is like a Node.js application that allows you to search for certain movies. It's like also a part of the tutorial in the MongoDB things, where you can just create a cluster, use your sample data, and just start building your things with MongoDB. And we're doing npm run dev. And I suppose he will now complain about, hey, this cluster does not exist. I configured the credentials, but the cluster doesn't exist, so those won't work anyway. And there's also like this coordinates to the cluster, which are wrong now. Let's see where our Terraform is. He's there provisioning. This brings me to the next part. Now we create some users. let's just assume that you're in a development team and someone says, hey, can you create me a user? Or you're just tired of ClickOpsing all the things and you give them like the admin user, and when you have to do a password rollover, things get pretty complicated since you don't know who actually uses this user. With Terraform, you can use like the database user. We create this one and use this for something else, or we can create a secret in OpenShift or Kubernetes. We can, I guess there's also an email provider, I hope so, where you can send emails out with the new credentials. Just imagine what you can do. We're gonna go ahead and say, hey, we create our user, and yeah, now he's complaining. This one. You see now the provider, the MongoDB provider, uses REST to create those resources and also to check like the state. And he says, hey, sorry, can't do that. And I guess we know why. I'm just going to load the sample data real quick, and then we're going back to the part where we are provisioning our mflix database here, to sample mflix, load sample data. And now we're going to create our user. The username should be mflix test. Maybe I already created one, I'm not quite sure. And the password is super secure. Since we don't want to commit this, we're going to use variable.db user password. Whatever comes to your mind, we're going to define a variable. Say this is sensitive. And the type is a string. The project ID we already defined, var.project ID, and the auth database, we just keep those as default, and we have those different roles. We're just gonna add the read any, or no, I guess we need to also write access. Let's just do that. And the scope is cluster, and we need the cluster name. So we go ahead, used our advanced cluster definition, say, hey, that's the name, zack. And this should create our user. We're going to do an apply. And since he already created the cluster and he has the cluster in his state, he won't create that one again. And he also says, hey, you created a new user. I would create that. And you also have the search index that failed recently. So we're just going to apply, say yes. And still the bad request. So I guess the database isn't loaded yet. Still loading my sample data. But he created my user. So let's just go ahead and test that one. And we now need, in our application, we need the server string. And since I propagated, hey, use Terraform for everything, we're just going to use Terraform for that one as well. And this can be done with outputs. You just add like the value, then you say, hey, what should we use? And we're going to use the, or I know that this is on the cluster coordinates. If you're not quite sure, you can always look it up in the documentation. PP. And we have like, yeah, where's this server string? Config server type. Maybe it's like connection. Return a connection string. Oh, great. And we already used the server. Since we're using a cluster, we're going to use the server record. So I'm not even have to type these things on my own. Zack. Copy and paste it. Now This was my free cluster, so he knows what connection string I would like. Let's do an apply again. And now he says, hey, you have these new connection strings. Since we add username and password into the connection string, I'm just going to copy this one, go back to my awesome application, add it over here, paste it. Just get the password again, this one here, and the username was, let's look it up in the code, mflixtest2. Yes, please. Hooray! So we completely destroyed our cluster and mapped it to Terraform, or previously we mapped it to Terraform, destroyed our cluster, and now my application should be working again since we're defined everything as code. So let's have a look. Oh, I need to restart the app again. User is not allowed to do the action find. Okay. So I guess the role of that user wasn't on point. Oh, the database was wrong. Sure. So let's go ahead and change the database. And this is like the fantastic part. I'm just going to add it to the code. Maybe I would do a pull request, and that's it. I don't have to click around in the UI. Maybe they rebranded and changed the UI or something like that. Just the code, and it works. I said, yeah, apply. Let's see if I refresh. Why isn't this working? Oh, okay. It just needed time until it gets propagated to the cluster. So now we have our MovieDB. We have a user here that we created with Terraform. And we normally would deploy this to your cluster, and you can create this secret. And we go ahead and look for our I have actually no idea what movies in there, but hopefully Die Hard. Yeah, Die Hard is here. So we have all our movies with the search index we created, that we first created as Terraform infrastructure as code. If I'm going to delete the search index, things won't work again. So complete success here. And this was actually all I wanted to show you today. The first step, you can now go home, make the main.terraform, main.tf, and start using Terraform for all your things. And just a quick recap, why you should use infrastructure as code, because you get consistency in your automation, or you get automation and consistency as well. You can collaborate with other users, make pull requests, you get your audit trail. And why use Terraform and MongoDB? Because with this approach, you can repeat your deployment. I mean, you really shouldn't destroy your cluster, but you can provide those search indexes to all your other stages that you use them. When someone changes something in a search index or something else, you see those changes, and you can make the decision whether you want to use this in your infrastructure as code part or not. And yeah, modularity, you've seen everything. And also, just a small thing on the best practice, use the prevent destroy on things you really don't want to want destroyed, because yeah, losing data is pretty expensive. And something that I haven't got into yet, but now I just manipulated my state locally. And if you're going to share your Terraform script, or your coworker is checking this code out, he won't have this state since it's on your machine and you didn't commit it, since it has sensitive information. So use something like Terraform Cloud or an S3 bucket or some backend that can manage those state, so everyone can contribute to this thing. And yeah, that's all there is. Questions?